Hello geometry students. In this video we're going to talk about inequalities involving one triangle. So let's start with a theorem called the exterior angle inequality theorem. You'll all recall what an exterior angle is. It's an angle like this angle 1 that is formed by extending the side of a triangle. And let's see what this theorem says. It says that the measure of an exterior angle is greater than the measure of either of its corresponding remote interior angles. Remember that with respect to angle 1, A and B, the two angles on the interior of the angle that 1 is not adjacent to, are called remote interior angles. So we will be proving this in later days, and if you recall that the exterior angle theorem tells us that angle 1 is equal to the sum of the measures of the two remote interior angles, so it would follow that angle 1 would be greater than either one of these angles. So let's use the theorem to fill in the blanks. The measure of angle 1 is greater than the measure of angle A, and also the measure of angle 1 is greater than the measure of angle B, because those are the two remote interior angles with respect to angle 1. So now let's use the exterior angle theorem to list the indicated angles. So we're going to list all angles whose measures are less than the measure of angle 7. So if you look at angle 7, 7 is an exterior angle to two angles. It's exterior to angle MKL, so it's exterior to this angle, but 7 is also an exterior angle to JKL. So so that means 7 would be, the measure of angle 7 would be greater than these two remote interior angles, and then when we look at the big triangle, 7 is greater than these two remote interior angles, if we add 2 and 4 together. So what that means is then that the measure of angle 7 is greater than angles, well, let's start with the big triangle, so it'd be greater than angles 1 and 2 and also 4. And then if you look at the small triangle, we've already listed 4, but in this smaller triangle, angle 7 would also be bigger than angle 5. And the reason why is because it's an exterior angle to both triangle MKL and also triangle LJK. And now let's list all angles whose measures are greater than the measure of angle 6. So angle 6 is an interior angle. So what we need to do is find any angles that would be an exterior angle where 6 would be a remote interior angle with respect to that. So 6 is in the interior of this angle. So we can see that one exterior angle would be, if we extend this side of the smaller triangle, angle 3 would be one angle. And then 6 is also an interior angle of this larger triangle. And when we extend side JK, we see that 8 is an exterior angle to this bigger triangle. So that means 6 is has a smaller measure than both angle 3, that's exterior to this smaller triangle, and angle 8, that's an exterior angle to this larger triangle. So we'll go ahead and list those, angles 3 and angle 8. Example 2 says, use the exterior angle inequality theorem to list the indicated angles again. So let's list all angles whose measures are less than the measure of angle 1. So angle 1 is an exterior angle to this triangle PQR, okay? So we know that angle 1 would be larger than this whole angle. So if it's larger than the whole angle 3 and 4 added together, that means it would be larger than 3 and 4 individually. And also, excuse me, the measure of angle 1 is bigger than this angle, so that means it would be bigger than 5 and 6 individually. So we know that angle 1, from the exterior angle inequality theorem, we know that angle 1 is bigger than angle 3. Oops, I'm writing that in the wrong place. Hold on, sorry. Angle 3 and angle 4 and angle 5 and angle 6. Okay, and part B says, list all angles whose measures are greater than the measure of angle 8. Well, 8 is an interior angle of triangle PQR, so we need to find an exterior angle where 8 is a remote interior angle with respect to that exterior angle. So if you look at angle 1, it is an exterior angle, but angle 8 is adjacent to angle 1. So angle 8 is not a remote interior angle with respect to angle 1. So let's see if we can find another one. How about this angle 2? If we extend side RQ, then we have an exterior angle. So we know that angle 2 is an exterior angle. Angle 8 is a remote interior angle with respect to angle 2. So we know that that angles 2's measure is bigger than the measure of angle 8, and I think that's the only one. Oops. Angle 2. So now let's look at a couple of theorems that have to do with the relationships between angles and sides within one triangle. So these are angle-side inequalities in a triangle theorem. So the first one says, if one side of a triangle is longer than the other side, then the angle opposite the longer side has a greater measure than the angle opposite the shorter side. So that's pretty wordy. So let's just reword that. Let's translate it. All this is saying is that the larger angle is opposite the longer side and the smaller angle is opposite the shorter side. So let's look at an example. In this example, we're told that xy is 9 and yz is 7. So let's fill in the correct inequality sign. So that means angle z, which is opposite the longer side, is going to be bigger than angle x, which is opposite the side that only measures 7. So the correct inequality sign would be to put a greater sign. Now this next greater than sign. This next theorem says if one angle of a triangle has a greater measure than another angle, then the side opposite the greater angle is longer than the side opposite the lesser angle. All right, so let's translate that. A shorter way of saying that is that the longer side is opposite the larger angle and the shorter side is opposite the smaller angle. So in this example, let's take a look at triangle JKL. If the measure of angle J is 110 and the measure of angle K is 45, then JL, now what's JL? JL is opposite the smaller angle and KL is opposite the bigger angle. So the correct inequality sign we would put in would be the less than symbol. Okay, the shorter side is opposite the smaller angle and the longer side is opposite the larger angle. Let's apply these theorems to a few examples. So example 3 says, list the sides and angles of triangle PQR from, now notice what it says, from smallest to largest. When you have quizzes and tests, pay attention to the question, because sometimes you'll be asked to list angles and sides from smallest to largest, and sometimes it'll be largest to smallest. So you don't want to miss points unnecessarily. Make sure you always read the question. So let's start with these sides. Let's find the smallest side. Well, the smallest side would be the side with the shortest measure, so that would be PR. So our shortest side is PR, okay? And then the next bigger side would be the side that measures 8.8, okay? So that would be PQ. And then that leaves the largest side of 9.1 to be QR. You can call it QR or RQ, it doesn't matter. Okay, so now we can use our theorem to say the smallest angle will be opposite the smallest side. So PR is the smallest side, so that means the smallest angle is angle Q. Okay, and then the next bigger side would be the 8.8, so that means the next bigger angle would be the side opposite that, so that would be angle R. And then the largest side is going to be opposite the largest angle. So I said that backwards. The largest angle is going to be opposite the largest side. So QR is the largest side. That makes angle P the largest angle. Okay, let's look at the next one. It says list the sides and angles of triangle ABC, again from smallest to largest. So the smallest side is this 3.7, so that's side AC. And then the next bigger side would be AB with a measure of 4.8, and then the biggest side is side BC or CB with a measure of 7. So now to list the angles smallest to largest, let's look at the smallest side is 3.7, so that means the smallest angle is angle B. And again, we're basing our answer not on necessarily what the diagram looks like, but how it's labeled. This is labeled as the smallest side, so we know that B is the smallest angle. And then the next bigger angle would be opposite side AB, so that would be angle C. And then the largest angle is opposite the largest side, so it would be opposite this side of 7, so that would be angle A. In example 5, it says, again, we're going to list the angles and sides of triangle FGH from smallest to largest. Okay, so this time we're given angles, so we're going to start by listing the smallest angle. You'll notice that we only know 2 of the 3 angles, but we can use our triangle sum theorem and the fact that the 3 angles total 180 to get that missing angle, which turns out to be 79 degrees, okay? So let's start by listing our smallest angle. Our smallest angle would be angle G of 45 degrees. And then the next bigger angle would be angle H at 56 degrees, and the largest angle is angle F. So now we can find the side smallest to largest. We'll start with that smallest angle is 45, so that means opposite it is the smallest side of FH, okay? And then the next bigger angle was the 56 degree angle, so that means the middle-sized side is FG. And then last but not least, the largest side would be opposite the largest angle. Our largest angle is 79, so opposite that angle would be side GH. All right. And then one more example of listing angles and sides from smallest to largest again. We have 2 of the 3 angles, so using your triangle angle sum theorem, we know that that missing angle would have to be 39 degrees. Okay, so that 39 degree angle is the smallest of the 3 angles, so we'll list angle X first, followed by angle W at 51 degrees, and then the largest angle is that right angle, angle Y, which of course is 90 degrees. So now to list the sides smallest to largest, 39 degrees is the smallest angle, so that means the side opposite is the smallest side. So side WY is the smallest, followed by side XY, that is opposite this 51 degree angle. And then last but not least would be the side opposite the right angle called the hypotenuse. That's our largest side, and it is WX. All right, so pretty straightforward theorems. If you have any questions, be sure and ask me in class.